All right, let's look at the first one. Did everybody get the first one, the quadratic formula problem? Who can tell me the quadratic formula? X equals what? Alex?
Negative b plus or minus square root positive b squared minus 4 ac over 2 over 4. 2 over, yes.
Yep. Now, when we do the quadratic formula, the equation has to be set equal to 0. Now, this one already is, but sometimes they're not. So you got to make sure you have it set equal to 0. Then you can clearly tell what your A is, what your B is, and what your C is. Okay, now, start plugging in, so the opposite of B will be 5. Now, you're putting in, this is B squared. B squared will be positive, always, right? If you're putting it in on your calculator and you do not put that -5 in parentheses, it's going to be wrong. It is easier, I think, truly, just to say, what is 5 squared? 25. And just write that down. Just write down 25. Don't be typing that into your calculator, because unless you use parentheses, it won't come out right. That has to be positive. -4 times A times C. All over 2A. So far, so good? So now we need to figure out what that is. So 5 plus or minus the square root of, okay, what is that going to be?
81.
Oh my gosh, 81? Well, that worked out great, because the square root of 81 is 9. If this had been 83, then we'd be done. But it's 81, so it's 9. And, oops, that's a 4. And I have to figure out both my answers. So 5 plus 9 is 14 divided by 4, 7 halves. 5 minus 9 divided by 4, -1. All right, did we get that one right? And if we didn't, have we figured out where we went wrong?
Are we allowed to put it as a decimal?
Like 3.5.
Yes, you can,
Okay.
yeah. Unless you're rounding it off, then it would be no. So if that had come out to be something else, like 7/6, and you rounded it off, it would be part points off.
Okay.
There is nothing wrong with fractions. All right, good on that one, because I'm gonna have to erase it to do the next one. You all set? Okay, now we're gonna complete the square. Oops. Completing the square means we have to move that number to the other side. So we're gonna have x squared minus 8x, and then I'm gonna leave the spot. I'm gonna, where that +5 was, I'm gonna leave that spot like this. Because I have to fill that blank in with a new number. Anybody remember how I find that new number? Half of 8 squared. So I'm gonna put a 16 here on both sides. So one more time, half of 8 squared. This right here, if you do it right, this right here will always be a square. What's gonna go in that parentheses? X minus 4? Yep, that's exactly what goes in there. Remember, that sign is that sign. Sometimes that will be a plus, but that sign matches that sign. X squared, 4 squared. And that equals 11. Now what?
Square root.
Square root both sides. So x minus 4 equals
Plus or minus.
plus or minus the square root of 11. And move the 4 over, nothing you can do with square root of 11. So x equals 4 plus or minus root 11. You may have written it like this, and that is perfectly fine. Anybody have a question about that one? Completing the square. Yep, something.
So for like, I understand the part where we take like half of the
Mhm.
second number.
Mhm.
But how did you do, or you got -4 from the 8?
Remember, you're factoring this.
Oh, okay, yeah.
So that's how that would factor, because I have to get a 16 and I have to have an 8, right?
Yeah.
Yeah, I'm just factoring it. But I want to write it this way so that when I square root it, it's just x minus 4. Okay, now I'm going to solve by graphing. Now, remember how the quadratic formula had to be set equal to 0? So does this one. Okay, you're finding the zeros. So this one is, but if it weren't, make sure you get it set equal to 0. All right, you go to y equals and put in our equation. Graph, got a nice little parabola. Kind of goes off the screen, but we talked about yesterday, we don't care about that because these are the points we're trying to find, right? So second trace 0. If this is the point I'm finding right here, your left bound will be here. That's where you want your left bound to be. And your right bound will be here. Because that point, and this is on the left, this is on the right of the point that I'm looking for. I'm surrounding that point. So I move my cursor and hit enter. Move my cursor and hit enter. And then when I take my guess, my guess is right there. So I'm gonna move that cursor and press enter. Who got negative 2.84 for that answer? That's one of them. That's this guy right here, x equals. Now, when I go to find this one, I have to start totally over. So second trace 0. And then my left bound will be over here now. This is the left side of that point. And my right bound will be up here because this is the right side of that point, to the right. So second trace 0. Moving my cursor so it's somewhere over here. Let's enter. And over there. And for that one, I got x equals 1.17. How about you? Does that sound right? All right, we're gonna do some lesson now, and then we'll come back and do a little bit more review, because guess what's gonna happen on Thursday?
Quiz.
We're gonna have a quiz. And you're gonna have on your these three problems. So you're gonna, the options are quadratic formula, completing the square, graphing, right? You won't be doing three problems, that takes too long, but you'll be doing two, okay? All right, so we'll practice again, but first we're gonna get our notes out. All right, ready? Today's lesson is, I think, one of the easiest ones we have. It is all about imaginary numbers. We ran into one of those yesterday. Where did it come from? How did we run into an imaginary number? Where did they come from?
Negative under a
We took the square root of a negative, right? That's how we did that. So let's look at P6. We're going to do some work with imaginary numbers. So it says we're going to simplify this and this. All right, any guesses about that first problem? I need to add these two numbers together. Anybody have a guess as to how we might do that? What? Now, this will be a FOIL. This is not a FOIL. Anybody tell me why this one's not a FOIL? They look a lot alike. That's a plus. Foiling means you are multiplying. So that one, we're gonna FOIL that. But this one, we're just gonna combine like terms. No great mystery here, nothing hard. We're gonna combine like terms. So what's our answer gonna be?
5 minus 4i squared. 5. Or 3.
3i? You have you have a positive 1 and a negative 4? We're adding them. We're on P6, number 1. All right, so we're gonna add the 3 and the 2. And we're gonna add the I and the negative 4i, that's it. This one's gonna be exactly the same thing, only we have to remember to distribute the negative. So we're gonna have 4 plus 3i minus 6 minus I. And then we combine like terms. So we'll end up with negative 2 plus 2i. So pay attention, that has a plus, you just collect like terms. This has a minus, so we distribute the negative, collect like terms. Now, this has nothing in there, which means it's a multiplication.
Yeah.
So we're gonna FOIL. So first times first, outsides, insides, and lasts. Now when you multiply a 2i times a negative 3i, we get negative 6i squared. 2 times negative 3, I times I.
Go see the nurse.
Email her and Now, what about this? We're not done.
You combine right here.
Okay, so these two are definitely addable. That one's not because it's an I squared, but these two are. So 12 minus 1i minus 6i squared. Now, do you remember something?
The square first.
What?
You put the, is it in the wrong order?
Oh, well, it's not in descending order. That's exactly right. If these were variables, x's, you're right. But this is special. Anybody know what I squared is? Do you remember?
Is it -1?
It is -1. I squared, if you have forgotten that, you need to put a box around that. Remember, I squared is -1. So every time you run into an I squared, you're gonna change it to a -1. So instead of being -6i squared, what's that gonna become?
Are you gonna sum it?
No. It's a multiply. So it's -6
6.
times
Yeah.
-1,
6.
+6. Now what?
You combine the 12 and the 6.
The 12 and the 6 will combine and we end up with 18 minus I as our answer. We'll never ever have an I squared in our answer. Because every time we have an I squared, we're gonna change it into a -1. All right, so we're getting ready to move on, but before I do, I wanna emphasize, we all get, this is not a FOIL, but this one is, right? We see the difference. Because I know on test day, sometimes we make that mistake. Electronic terms, FOIL. All right, and how about D? D is division. Do you remember anything about how to do problems that look like this? Jake?
Don't you like multiply it by the same thing? Like you do parentheses.
Uh-huh.
And
It's
it'd be
not
like,
quite exactly the same thing.
or you flip it or something.
He's exactly right. This is what we're gonna do. We're gonna multiply the top and the bottom by something.
There's different.
What?
Like the top and the bottom.
We're gonna multiply by what we call the conjugate. And the conjugate
So it's opposite.
is the same thing as the bottom, only you change that little sign. So instead of 6 minus I, it would be 6 plus I. And we always use the bottom. If we put a 6 plus I on the bottom, we have to put a 6 plus I on the top. Okay, real quick. What if we had this? What would we multiply by? 4 plus 6i. So it's we use the conjugate at the bottom, and the conjugate says you change the middle sign. Okay? And it's always the bottom that we do that with. Okay, so now we've got this big thing. What do you think we ought to do now? FOIL, not just once, but twice. We got a FOIL on the top, and we got a FOIL on the bottom. So, here we go, on the top. First, outside, inside, last. Remember, when you multiply a 3i times an I, you're gonna get 3i squared. And we're gonna do something with that, but not yet, one thing at a time. All right, what's my denominator? Who will read it off for me? First,
36
outside,
plus 6i.
inside, inside,
Negative 6i
and last,
squared.
negative I squared, because it's a positive times a negative, right? Now, gang, I want you to look at that bottom. What do you notice about the bottom?
It can cancel.
These cancel, that's why we did it. That's why we did it. And what about negative I squared?
Or
Positive 1. Because I squared is negative 1. So a negative negative 1 would be 1. So isn't your denominator just 37?
yes.
Okay, that's why we did it, you guys. You're not allowed to have i's in the bottom. So in the beginning, we had an I in the bottom. Can't have it. So we multiplied by the conjugate, and now the I in the bottom is gone. That will always happen. Now, there's gonna be i's in the top, but that's okay. 30 plus 23i what's 3i squared? Negative 3. So it looks like my final answer after all that will be 27 plus 23i over 37. Does that look about right? While we're here, let's talk a little bit about canceling. Obviously, nothing cancels in this problem. But we could have done it, we could have ended up with 16 minus 40i over 8. We ended up with something like that. You can cancel that. You see? You can take an 8 out of everything. So if I take an 8 into 16, it goes twice. An 8 into 40, it goes 5 times. And an 8 into 8, it goes once. And so I would just end up with 2 minus 5i over 1, or just 2 minus 5i. But if it would have been this, I can't cancel. That doesn't simplify. Because the rule says, if you have 3 numbers in your fraction, and you want to simplify, you have to be able to do it with all 3. You can't just simplify these 2. So that one doesn't simplify.
Sorry, I was gonna say for the beginning of the first problem, like at the denominator 6 minus I, could you turn the negative I to like I thirds to like cancel out, or I to the third?
No. Well, negative I is I cubed, but who in the heck would want to do that, right? Because then there's no way around it, you're gonna have to use the conjugate, and I'd rather use the conjugate with a smaller power of I than a bigger power of I.
Okay.
Yeah, there's no way to cancel. No way to cancel in this problem. This is a 4-part problem. And we're saying rule, if you're gonna do any canceling in this fraction, you have to be able to cancel it out of all 4 parts. So the temptation might be to cancel the i's, but you can't because there's no i's over here to cancel. Okay, no canceling in a multi-part fraction unless you can cancel every single piece of that fraction. Okay, good questions. Anybody else? All right, let's look at E. We're gonna practice some more of these, but let's get through the main part of this. Square root of negative 81, what do you think, guys?
Take an I out.
Take an I out, well,
Take the negative.
The negative
yeah.
comes out as an I, you're exactly right, so it'd be I root 81.
Square root of 81 is 9.
Yep, so the answer is 99. We talked about that a little bit yesterday when we ran into that problem. When you have the square root of a negative, the first thing you have to do is take that I out, like Ron said. So I want you to listen to what I just said, I'm gonna say it again. When you have a square root of a negative, the first thing you do is take the I out. So the very first thing I'm gonna do is make this I root 4 and this I root 9. That is step 1. Now, square root of 4 is 2. So this is like 2i. And this is 3i. Now I'm gonna multiply them, and what am I gonna get when I multiply them? 6i squared. And I squared is -1, so my answer is negative,
Oh, sorry, I did not mean to say that.
negative 6. Negative 6. You have an answer?
I was at the college visit.
Oh. We good?
Yeah.
Okay, well, let's look at the next one. These problems always freak us out. And they shouldn't, because they're really, really easy. Let's see if you can figure it out. Your job is to tell me what is X and what is Y. Use your common sense and look at the problem. What do you think X and Y are? There's no work. Do not set up equations. Do not do anything weird. What do you think X and Y are? You have a guess what X is?
3.
What?
3.
3. X is 3. Very, very good. X is 3. Is she coming?
She had asked a question.
X is 3. What do you think about Y?
2.
2. Easy peasy, guys. X is 3 and Y is 2. Why? Well, look at this number. Does it have 2 parts?
Yes.
One part is just a plain number, and one part has an I. Okay? Same thing over here. We have a plain number, and this one has an I. If they are equal, the plain parts are equal, the plain parts are equal, and the I parts are equal. That's it. That's all there is to it. So when I look at the next one, I'm not going to get all freaked out. Look at both sides. What are the plain parts? What's the plain part over here? 3. What's the plain part over there?
X.
So X is 3, done. What's the I part over here? Watch it, negative Y. And what's the I part over here? 7. So negative Y is 7, so Y must be negative 7. Kids, that's all there is to it. When you have 2 complex numbers, they're called complex numbers, they have I's in them. They have I's in them, they're called complex. If you have 2 complex numbers equal to each other, their real parts are equal, their whole, regular, normal parts are equal, and their I parts are equal. Okay? All right. Now we have a little bit of review here. Part 3. 2A and B are solved problems. So I'm gonna mix up the directions a little bit here. And for A, I need a volunteer or a team of volunteers. I want you to complete the square. So you can bring your notes if you want, if you need them. Come alone or with a partner. And then for B, I'm gonna have you use the quadratic formula. Okay, so, I don't hear a crushing stampede of volunteers.
Here, I can do the quadratic formula one. You wanna come with me?
Come on now, we're
Already done it?
working on this.
Never mind, you should do the square one. Oh, never mind.
So we are practicing for our quiz a little bit.
This is so perfect.
And then it's 81.
Here, plug it in the couch. Wow, this is so perfect, okay.
Or- And then, yeah. Wait. Back out. Right back out. That's nice.
Square thing we have there.
So,
Is that right? It should be two. Yeah, it should be two. And then, I don't know what that plus or minus is, we need to erase that. No, that plus or minus is after your parentheses. And put that in front of the two on the other side. There you go. So you have x plus two, you square root of both sides. So you have x plus two. Oh, it's on the last step, should be x plus two, not four. Equals plus or minus root two. There you go. Now subtract two. And you're done. Let's say x equals negative two plus or minus root two. I can tell you, there's a negative in front of that two.
It's half of 4
All right, now do you understand the mistakes that you made up there? All right, friends, I think we got two right answers up here. I think we're all good. They, and it's fine, it's totally fine. They got underneath this radical right here. They got 25. So that's where this 5 came from. When they did this math right here, they got 25. And the square root of 25 is 5. So 9 plus 5 is 14 over 4, which they reduced to 7 halves. and 9 minus 5 is 4 over 4, which they reduce to 1. Anybody have a question about the quadratic formula problem? Okay, completing the square. First thing they did was move that 2 to the other side. Right?
Yes.
And then they figured out what they were gonna add in here. How do we figure out what we are gonna add in? Oh, I love these little, they're so good. And, oh my gosh, the first year she worked here, I taught the nurse, by the way, back in the old days. I know.
Miss
I'm
Fo,
old,
wait,
man,
Miss Fo's
I'm
like my
old.
best.
So anyway,
I love this.
she brought me these tomatoes and she just brought me like tons. And I ate like almost all of them. And I got these awful sores inside my mouth because these are acidic. And I ate like probably 2 pounds of them. And anyway, so now she limits me. Now I just get little bags so that I don't end up being a glutton. All right, so here we go. Half of 2 squared is 4, we're gonna add, half of 4 is 2 squared is 4, so we're gonna add 4 to both sides. This right here, after you add that 4 to both sides, this is gonna become a perfect square. That's a plus, so that's a plus. We have x squared and 2 squared. They square rooted both sides. X plus 2 is plus or minus root 2, and then move the 2 over. That's perfectly done. Anybody have a question about that one? Okay. Then we got a couple more review problems. Now this is today's lesson, so this will not be on our quiz, but we do need to practice it again. So we have a FOIL problem, and then we have a division problem. So I need new volunteers, someone new, who will come up and FOIL that one. And who will come up and we call it rationalize this one. Okay, waiting on my volunteers. Oh, good. Are you guys together?
Yeah, we're foiling.
You're foiling, all right. Who's gonna come up and do the Riley and do the division? Perfect.
Oh, I see.
She should have 13.
Yeah.
I don't know if that was negative.
Everybody should be working on these now. Nobody's just sitting. We're not on vacation. So you knew you needed the conjugate. It's only the conjugate of the bottom, and we multiply the bottom and the top by it. So let's start over. So you knew something was wrong because things weren't canceling, right?
Yeah.
Yeah, we knew that, so, yeah. So go ahead and write your problem, and then we are gonna multiply the top and the bottom both by the same thing, okay? We gotta always do the top and bottom by the same thing. And the same thing is going to be 3 plus 2i. So you're gonna put 3 plus 2i.
With the, so this and then
Top and bottom, yep, so, both of them are gonna get 3 plus 2i. Yep, so step aside, does everybody see this now? That's how you wanna do it. We always use the conjugate of the bottom, and we do it on the top and the bottom. Okay, go ahead and start foiling now, and hopefully things will happen. When you do this process, the goal is to end up with a single number in the denominator. That did not happen for Riley, so he knew something was wrong, because that should always happen. You should always end up with just a number in the bottom. So let's see if he does.
but the top two.
That should be a 14i squared.
This one?
On top, 14i squared, because you multiplied 7i times 2i.
Yeah.
Yeah.
And then so we have these two here.
Yep. Mm-hmm.
-14.
Yep, -14, perfect. Mm-hmm. Yep, all looks good. Mm-hmm. Bingo. There it is. I match what's on the board. Do you all match what's on the board? Both problems?
Yep.
Got it?
Got it.
All right. Two more things to do. P6 will be due on Thursday. P6 will be due on Thursday. We're gonna start P7, go a little bit of P7, then we're gonna review again for our quiz. As I promised. Everybody good with this?
Yeah.
All right. Now we're moving on to P7. Which is some absolute value inequalities to start, and then some quadratic inequalities. All right, there's lots of ways to do problems every time. It's one of the most fun things about math is we can all do the problems a little bit different way. I want you to think back. I'm going to try to stick with what you've done before. How did you solved these before, last year and in Algebra 1. Do you remember how you solved these?
We graph.
I like to do it on an line. That's how I like to do it. But none of the other teachers do it that way, so I don't want to confuse you. But if you really can't remember, then I'm going to show you what I think is the easiest way in the world to do it. I just draw a number line. Right in the middle of my number line, I put the opposite of the number that's in the absolute value. So the opposite would just be positive 2. Okay, so I draw a number line. Right in the middle of the number line goes the opposite of that number. If it had been x plus 2, I put negative 2. Then I start at 2 and I count forward that many and backward that many. Where will I be if I start at 2 and count forward 3? 5. And where will I be if I start at 2 and go backwards 3?
-1.
And I put open dots there at those two numbers because, see that guy right there? He doesn't have an or equal to. If there'd been a line here, then those two dots would be closed. They're open. So I got a number line and I have 2 dots on my number line. When you have 2 dots on your number line, you're either going to shade in between the 2 dots or you're going to shade outside of the dots. Do you have any idea how you tell whether you shade in between or outside?
No.
It has to do with this sign right here. This is a greater than. I want you to think about this for a minute. Where are the greater numbers? Out. They're out. Always we're going to shade in between or we're going to shade out. Greater than means shade out. So I'm going to shade this way on my number line and this way on my number line, and that's the answer to the question. So everything from negative infinity to negative 1, that's that part shaded in. Negative infinity, negative 1. Or, this is the mathematical symbol for or, it's called the union symbol. And whenever you have 2 parts shaded, you're going to link them with an or, with a U. So we have this piece shaded, or we have this piece shaded as part of our answer. All right, let's see if you picked any of that up. Here's my number line. You start right in the middle. What number is going to go in the middle? 5. Negative 5. Because what do we put in the middle? We always put the opposite of what's in the parentheses. Guys, remember when you factored? And you factored a problem and you got, something like this? What did you say the answers were? The answers were negative 3 and positive 2? Wasn't it the opposite of what was in the parentheses?
Yeah.
This is the same thing. It's the opposite of what's in the absolute value. So it's negative 5. Now, I'm going to count forward 6 and put a closed dot. And I'm going to count backwards 6 and put a closed dot. So starting at negative 5 and going forward 6, where am I going to be? 1. Starting at negative 5 and going backward 6, negative 11. Now I got my dots. What did I tell you about shading? You're always gonna shade in between the two dots, or you're going to shade
Out.
outside of the dots. Since this is a less than, we're going to shade in
Inside
between the
here.
dots. So my answer is bracket -11 to 1. There's my integral notation. Okay? What is a little bit different about C? We have a number in front of the X. Guess what? That number cannot be there. Do you have any idea what we might do? What would you do with it if it was a regular equation? Pretend the absolute value weren't there. What would you do? Divide? That's what we're gonna do. We're gonna divide by 2. Everything by 2. So now my equation is x minus 4 is greater than or equal to 7/2, or you guys will like 3.5 better. Doesn't matter, 7/2, 3.5.
Isn't it a thing like if you're dividing by a negative, the sign will change?
If I'm dividing by a negative, what am I dividing by
A
also?
positive.
Yeah.
I just want.
That is a thing, but it doesn't apply here because I'm dividing by a positive. Okay, so here's my number line. What's gonna go right smack dab in the middle?
Positive 4.
Positive 4. Not a dot. The dots are out here. I get the dots by counting forward and backward. How much? 3.5. So 4 plus 3.5? 4 minus 3.5? So here are my dots. Now I just need to look at my problem. Am I shading between the dots or outside the dots?
Outside.
Outside the dots. Because it is a greater than problem, and boys and girls, that's where greater thans get graphed. So what's my answer? Negative infinity to 0.5. This would be a bracket, or parentheses, this would be a bracket. Or, remember, when there's 2 parts to your answer, 2 or more parts to your answer, you link them with a U or union. Bracket 7.5 infinity. Wow. All right. One more, and we'll put some review up here. This next one has all kinds of things wrong with it.
Oh, great.
What do you notice wrong with it? First of all, for me, it's backwards. I don't like that, okay? Here is, it's magnificent. I am allowed, if I don't like the order that it's in, I'm allowed just to turn it around. And you're thinking, whoa, whoa, whoa. You can't just turn around. If you're doing 7 minus 3 and 3 minus 7, you can't just turn it around because these are not the same thing, right? But what if they're an absolute value? Are Are they the same thing if they're an absolute value? They are. They are. So don't be turning around subtractions randomly. But if they're inside absolute value, you're allowed to. Because the absolute value of 4 and the absolute value of -4 are the same thing. So I'm gonna turn it around. All right, now what's wrong with it?
Divide.
I can divide everything by 4. Now, of course, I do not have a fraction aversion. Fractions are my friends. So I have no issue with that. But if you prefer, it's gonna help you do the arithmetic, you can do that for sure. It doesn't matter. As long as we're not rounding off, and we're not, it's fine. So now I'm going to draw my number line. What is gonna go right in the center of the number line?
Positive 3/4.
Positive 3/4 or positive 0.75, whichever you prefer. You want me to do 3/4?
No.
No. And now I'm gonna count out that way and back this way. And I have to figure out what those dots are. And how am I gonna figure out what those dots are? I'm gonna start at 0.75. And I'm gonna add 2.25. And is that gonna give me 3?
2 point. Oh, yeah.
And then I'm gonna take 0.75 and back up. 2.25,
Negative 1.5.
and that's gonna put me at negative 1.5. I think, is that right? 3/4, 6/4, yeah.
Less.
Or so it's inside.
Since it's a less than problem, we're gonna shade in between.
Oh, yeah.
Open dots. Negative 1.5, comma 3 is our answer.
Beautiful.
Got it? All right, I'm gonna pause there. And remember the piece of paper you got out at the very, very beginning of class? Let's turn it over. And let's do 3 more practice problems.
Let's do it.
Yep.